So continuing this lesson, today we're going to add an extra step. And then so I changed the title here to kind of show what we're going to be doing. Here I am using factor as a verb. This is the action you will take. So for example, let me just show you one of the problems we started with yesterday. The first one I showed you yesterday was this, and we talked about how we were going to divide both parts. We broke it into separate pieces. So here's the deal. This is one of the factors, and your answer. These are the two factors that if we multiply them would make that polynomial that's in the numerator, right? So we've kind of already talked about that in the last two lessons, that this number we divide by is a factor and that the answer is the other factor. If we were to multiply those two things, we would get back to the original polynomial. Okay, so that's just kind of reviewing that vocabulary of how we're using factors in this sort of algebraic way. So here's the challenge that we now need to do. The new part of this lesson is to find the first factor. In all the work we've done, this factor has been given to us, either showing it like this as a denominator that we could divide, or you don't need to write this down if you don't want to, but in the previous lesson 5.2, we did, I'll just show you a quick example. We had something like this, where they gave you the first factor like this, and you had to find the second one, right, this kind of factoring. They also gave you the first factor. So there's two different ways we could show it. We could show it as dividing, and then the answer is the other factor, or we could show the two factors being multiplied. But again, the difference in what we've already done is that in what we've already done, they've given you the first factor. Now the challenge is going to be you have to find that factor and then find the second one as well. Okay? So for example, your instructions will say factor. That's a verb, telling you what to do. Factor this polynomial. This first one, 5x squared plus 10x. We'll start with a binomial. Now the idea here is we need to find the greatest common factor of these terms. That means we're looking at the numbers and we're looking at the variables. The idea here is that we're going to want to end up dividing this to find the second factor. If I factor this, it means find the two factors that could multiply to make this binomial. So we're going to start by finding a common factor that we could divide, just like we did in yesterday's lesson, and then we're going to use that factor that we divide to find the second factor. Does that make sense so far? What we're going to be doing, what we're looking for? Kinda? Let's try it. 5 and 10. What's the least common factor? That's right, the least. Excuse me. The greatest common factor of 5 and 10. The biggest number that goes into both. Izzy? 5. Right? Remember, it has to be divisible by both. So we can't do 10, because 5 divided by 10, well, we'll end up with a fraction. It's 5 divided by 5, 10 divided by 5, that will work. Now, notice we're taking the greatest common factor for both, but it's going to be smaller than some of them. So between x squared and x, the greatest common factor is x. The idea here, guys, is that we don't want to have a variable in the bottom that has a bigger exponent than one of the ones in the top. X is the most we can take out of both of these, is the other way to think about it. If we wanted to write it side by side, like these, remember these that we did up here where you had the first one and then you had to find the second one? If we wanted to write it side by side, we could. We could say 5x times something else. Or again, the second way to think about it is to put it as a denominator, and when you divide, the answer is that second factor. So let's try it first with the dividing way, and then we'll get to doing the side by side. If I do 5 divided by 5, now remember, this is from yesterday's lesson, I need to divide both of these pieces by 5x. I'm not rewriting it, I'm just going to do it mental math. 5 divided by 5 is 1. X squared divided by x, what do I get? Jaden? Good, I get 1, right? If I could get rid of 1 from the denominator, I could get rid of 1 from the numerator, which means there's 1 left. Okay, so this is what we were doing yesterday. I didn't rewrite it separately, but we are doing the same thing. So if it helps you to rewrite it like this, with both of them have the 5x so that you can cancel, then do that. Okay, The next piece, 10x divided by 5x, or if you look at it here where I've written it separately, 10 divided by 5 is 2, x divided by x, they cancel out. How do we know if we got it right? We could take our answer and multiply it. We would distribute the 5x times x makes 5x squared, 5x times 2 makes 10x. So we have to find the greatest amount that can divide out of both terms. That's the challenge for today, is to find that first factor, then to use it to find the second factor. Let's try another one that's just a binomial, just to get going, and then we'll get to a trinomial. How about 15m squared minus 9? What is the greatest common factor of 15 and 9? The biggest number that could divide evenly into both of them. Carissa?
3.
Good, 3. What about m's? Can I take an m out of both of these terms in the numerator? Good, I see thumbs down. There's no m here. How can I take an m from here if there's nothing here? So in this case, greatest common factor, just 3. Because there's not an m in both, I can't take an m out. So now I would divide both of these. Now the answer again, we've got two factors, 3 and our answer. 15 divided by 3 is 5. M squared, oh well I can't cancel anything because there's no m's in the denominator. 9 divided by 3, 3. Here are my two factors. Now again, when you do this division by 3, if it helps you to write it separately so that you can cancel, then you can go ahead and do that. If you can do it mentally, just looking, then you can do that. Let's do another one. Let's get to a trinomial. Let's go 4x to the 5th minus 6x cubed plus 14x. Now let's try this one with the side-by-side method. The first factor isn't given to us, so let's see if we can find it. Now you can use either method. You can show it as a denominator and divide it, or you can do this. I don't care which method you prefer. 4, 6, and 14. What's my greatest common factor of those three numbers? Now that we have 3 of them, 4, 6, and 14, biggest number that divides into all of them, Jaden?
2.
Good, 2. X to the 5th, x cubed, and x. What's the greatest amount of x's that I could divide out of all three parts? Vincent? Just 1. So basically the idea is the smallest of the variables is going to be a part of the greatest common factor. Because I can't take an x squared and x cubed, anything bigger out of this one, so that's what I use. Okay, let's see if we can figure out what would be left over. Now again, the other way is to think of it as dividing that 2x. But if I just want to go side by side and I go, okay, 2x times something makes 4x to the 5th. How did I get to 4x to the 5th? Well, I must have gone 2 times 2 to get 4. X times what would make x to the 5th? Diego?
X to the power of 4.
Good, x to the power of 4, right? If I multiply the same base, I would add the exponents. Okay, next, I keep my minus. I'm going from 2x times something that would make this, right? Or you could look at it as dividing it, going the other way. 2 times 3 is how I get the 6. From x to x cubed, I must have multiplied by x squared. Finally, from 2x to 14x, well, 2 times 7 makes 14, and x, oh, there's no more x's. Now, if the side-by-side is confusing for you, just do it this way. 4 divided by 2 is 2, x to the 5th divided by x to the 4th. Negative divided by positive, 6 divided by 2 is 3, cubed divided by 1, x squared, 14 divided by 2 is 7, x and x, they cancel out. There's our second factor. Make sense? It's a little trickier. I know it's a little bit harder. Okay, so that's the idea for today, to be factoring. Now, because we have a decent amount of time left before lunch, and then also we have a day off tomorrow, I'm going to give you a little extra practice of some of the previous topics.